So the people in the Central Time Zone, Eastern Time Zone, good morning. Anything east of there, Atlantic Time Zone onward, it's good afternoon and good evening. Welcome to NFCA's webinar series. I'm Bill McHugh, the Executive Director of the National Fireproofing Contractors Association. First things first, let's do a quick sound check and make sure you can hear me. So go ahead and put your hand up on the control panel if you can hear me. Just doing a sound check. Good, you can hear me then. That's awesome. You can probably see me because we've got the cameras on. Awesome. Okay, sounds good. Let's try this again. So good morning, good afternoon, good evening. Welcome to NFCA's webinar series. This one, the NFCA and fire resistance and the guide information at ul.com/PIQ, in other words, product IQ. Kevin Hyland joins us, the PDE principal engineer at UL Solutions for fire resistance. And then also Rich Walke joins us, consultant to the NFCA with CTI Creative Technology Inc. Rich has 43 plus years experience in the industry, 43 of it with UL. And then Kevin's been with UL for quite some time and recently, I guess 2 years ago, moved into the PDE role over there at UL. So welcome to this webinar. We've got some introductory slides we're going to get going with, because if I didn't do this, I wouldn't be doing my job. First things first, got to thank the NFCA Board of Directors. Carl Fernald, Steve Winston, Matt Stevenson, Nikita Gordon, Adam Carter, John Wall, Don Arman, who just stepped in for Keith Kennedy, who retired in 21, Bob Poole, Paul Steele, Matthew Strader, and then also Neil Rivers, Easley and Rivers. His company actually had a person that was the first president of the NFCA, Daniela Lopez, George Fine, who took over for retired director John Taglianti. Cool thing is that these guys, as they retire or roll off the board as past presidents, stay hugely involved in the association, providing some valuable input. And then, as I had mentioned, valuable input comes from Howard Towler and Bubba Winston, as well as our director emeritus people as well. So what's the NFCA do? A whole bunch of stuff. I mean, if you think about it, since 2014, the NFCA has gotten involved in a lot of different places, whether it's ASTM, the NFPA, International Code Council, liaisoning with the American Institute of Steel Construction, American Iron and Steel Institute, the National Building Code of Canada, where we put in several code proposals last week, the Society of Fire Protection Engineers, where I've spent time with the SFPE at their industry leader luncheon to represent the passive fire protection industry as well, or international accreditation services and more. We've been a lot of different places, and we continue to be those places as well. Recently, we're at the International Code Council, Canadian Code Development Process, and the NFPA Code Development Process just finished up. This picture up here in the upper left is the committee action hearings for the International Code Council. It took place in lovely Rochester, New York in early April, so March 31st, April 1 through about April 10. Yes, it snowed. Yes, we had all kinds of fun. Doing what? Representing the fire resistance industry at the International Code Council's code development hearings. The UL Qualified Fireproofing Contractor Program, the NFCA worked with UL to relaunch this right at the beginning of COVID, actually, if you think about it. April of 2020 is when we relaunched this. Contractors are in the queue, and there's a bunch of companies about ready to get qualified, and we look for that program to take off over the next several years. The NFCA's Handbook of Accepted Fireproofing Knowledge supports the exams, the NFCA fireproofing exams for IFRM and SFRM. It's fireproofing all in one place. Great book. Rich Walke was a big help, helping me get it over the top and finished. We had developed a lot of the book, and over a period of, I don't know, 3-4 months, Rich and I were able to make it a public document and finish things off. Moving on, our education exams continue at NFCA. We've got virtual education exams taking place November 9 to 11. So if you want to get educated and take the NFCA fireproofing exam, which is the first step to become a UL qualified fireproofing contractor, or the NFCA accredited fireproofing contractor. You know, that NFCA accredited fireproofing contractor program is the first step to get yourself to the UL program. Got to be a DRI. The only way you can be a DRI is if that NFCA accredited contractor company appoints you as such. So November 9 to 11, we'll be doing the education exams, and then we'll do them live at our NFCA Week of Learning in the spring of 2023. Our Award of Excellence takes place at the conference next year. January 31 of 2023 is when our deadline is for the Award of Excellence. Look for more information on that to come in November, December as well. So, one big program that I think we need to make sure the industry knows about, to the contractors, to the manufacturers, to the associates, and in the fireproofing inspection agencies. Rich and I recorded a program on UL 263 and E119, the basics of it. And I think what we're going to do is take this program that we're doing today and record it and stick it right underneath this one, because these two programs go together. First, what's the standard UL 263 and how does it work? And then second, what are the information that's not necessarily in the UL product IQ, that's over at the guide information? What common elements are there? We'll publish this right underneath it at nfca-online.org. So NFCA does a lot. World-class education program, the accreditation program, which is recognized worldwide. We've got companies that have been approved or certificated, I should say, the accreditation program from NFCA in Mexico, the US, Canada, India, and the Middle East. It's starting to be worldwide, something that didn't happen 8 years ago when we started working with the NFCA. The UL Qualified Contractor Program starting to go, and watch for our Week of Learning. That's coming up here shortly, and we'll start promoting it once we have the venue nailed down. We're pretty close and should have it nailed down in the next couple of weeks. The NFCA 100 through 400 standards are also great tools, resources for contractors to use, general contractors, architects, specifiers as well. NFCA continues its work, though, technically at the International Code Council, NFPA, and the National Building Code of Canada to bring our technical expertise from the field to the code and standards development processes at ICC, NFPA, National Building Code of Canada will be over in India here shortly, as well as over into parts of Australia and New Zealand. And where do you find the experts in fireproofing? nfca-online.org is where you find them. So a big thanks to members. It's your dues that help pay for us to do what we do. To be in Florida, where Rich was last week, representing the NFCA on several code proposals as the Florida Building Code was being developed for its new code. Got some good stuff that went through. You'll hear about it in the near future. Certainly the Contractor Accreditation Program. All the things you see at NFCA don't take place unless we have dues from our contractor members, manufacturer members, supplier members, associate members. So if you're a member, thanks. If you're not, we need to reach out through the camera into your wallet, grab that credit card, and charge it today. Contact Kristen at nfca-online.org for an application, and off we'll go. So let's jump over to what we were here to talk about today, which is the NFCA's program on fire resistance and the guide information at UL's Product IQ. So what I'm going to do now is turn the slides over to Rich. He's going to accept it and then put his screen up, and then off we'll go. So Rich Walke, the floor is yours. Kevin Highland, you're there too. Really glad to have two major resources in our industry presenting today to give you the best of the best in fireproofing. Remember, questions are welcome anytime. Type them in, either chat or in the question box. We'll get to them at the end, and we'll keep these questions going as long as you people put them in. So thanks Floor is yours, guys.
Okay, great. Thank you, Bill. Thanks for the introduction, and thanks for that great information about the association. Good morning, good afternoon, good evening to those of you in the audience. Thanks for joining us here today. We've got an interesting program put together. I will be sharing this next portion of the program with Kevin Highland from UL. Kevin and I worked together at UL for a number of years, and it's always good to be working with him again. So we're going to talk about three basic items today, all relating to the UL published information on fire resistance. We're going to start by giving a very quick overview of the three components which make up the UL certifications for fire resistance. And that would include the guide information, which is really the focus of today's program. And we'll talk about how the individual designs fit into the picture, and likewise how the manufacturer certification pages interact with the designs and guide information. And then Kevin will talk about locating information on locating the guide information on UL's Product IQ online directory. And then Kevin and I will share the responsibilities for discussing the content of the guide information as it pertains to your industry, the fireproofing industry. So let's see, okay. The three components of the US-based guide information really consist then of the guide information, the designs, and the product categories. And these three components interact to give us the overall picture of the certification information for fire resistance. And to get started, let me just say that UL categories is all of the hundreds of thousands of products that they list under product categories. Each product category will give a verbal name or description of what that product covers, or that category covers. And in most cases, that product category name is descriptive of the products or assemblies that are described in that category. For example, fire resistance ratings based on ANSI UL 263 is descriptive of what we're referring to today, those listed fire resistive designs. Each product category also includes a 4 or 5 character category control number, or CCN, which is in reality just simply a computer code. If you happen to know that computer code, for example, BXUV, it makes for an easy way to get to the listings on the UL Product IQ. So the categories that we're interested in as far as fire resistance is concerned, as far as the designs is fire resistance ratings, BXUV, or fire resistance ratings by ANSI UL 1709 for the rapid rise petrochemical applications. CCN on that one is BYBU. And then there's a series of product categories which cover the materials used in those designs to provide the protection. Spray applied fire resistant materials, intumescent fire resistant materials, batten blankets, mineral and fiber boards, matte materials, and gypsum board are those products we typically think of as being used to provide the fire resistance ratings. And the other point to make is the individual product categories, for example, gypsum board, also includes guide information that talks about the use of the gypsum board. And then when we come to Canadian certifications, we likewise have a series of product categories, each which is described by a name and then the category control number. For the most part, the names of those product categories will end with the phrase certified for Canada to very clearly identify the fact these are certifications based on Canadian codes and Canadian standards. So anytime you see that phrase, it is purely Canadian work intended for use in Canada. The CCNs for Canada will end in either a 7 or a C. And probably asking, why do we have two suffixes for the Canadian work? Well, the categories which end in the number 7 are categories, listings, and certifications which are published by UL Solutions. I guess I'll say the parent company of UL. The categories that end in the letter C are published by Underwriters Laboratories of Canada, which is a Canadian affiliate of UL. So at some point in time, those categories will be merged. UL has not yet got to that point of doing that, but in reality, either of the categories, the 7 categories or the C categories, relate to certifications intended for Canada. First case with a 7, those are certifications from UL, typically referred to as CUL listings, and those ending in the letter C are UL of Canada listings. So likewise with the various product categories, they'll either end with the 7 or the C suffix. So let's talk about each of those individual components of the certification information at this point. The guide information is our primary focus here today, and more specifically the guide information relating to BXUV fire resistance ratings to ANSI UL 263. And the guide information for BXUV is probably, if not the most complete guide information published by UL. Many, many pages long, lots of very informative information. We used to have an index of that guide information, and there were something like 95 individual topics covered by this guide information. So it is imperative that you know the guide information is there, and you know how to use that information and how we use it in conjunction with the use of the individual designs. So in general terms, excuse me, the guide information starts with the equipment, materials, and systems included in the category. And that applies across the board regardless of what the category is. Most of the time, the guide information will start with a sentence, this product category covers such and such. Very easy to understand whether you're in the right category just by reading that first line. And then it includes intended uses, restrictions, and supplemental information that apply. And that's where BXUV is really useful. It contains pages and pages and items of intended uses, restrictions, and supplemental information. All the guide information also gives the standard by which those products are evaluated. That way you have a very quick way of keying in, are the listings I'm looking at appropriate for what I'm trying to do at this point in time? I'm trying to enforce the provisions of Chapter 7 of the IBC. Chapter 7 references UL 263. We see that information in the guide information, we know we're in the right product category. And then those product categories that cover the actual products will also include a description of what the listing or classification mark or certification mark should look like for those products. If you're out in the field, you see a certification mark that doesn't quite look right, go to the guide information. See it, does this listing mark show the information it's supposed to be showing? And if not, let UL know, and UL can investigate whether that's a legitimate marking or not. So then, of course, each individual UL design is a specific construction which covers certain construction features and ultimately concludes with, if you build this assembly as described in the design, this is the hourly rating that you would achieve. And most all of the designs do have multiple options, so you do need to read all those options, all those variations. Sometimes those variations will impact the ratings, sometimes they won't, but you need to read that design carefully. And in case of direct applied fire resistant type materials, those designs will give you the thickness that's required for the required hourly rating for your project. And again, most designs contain a number of options and various ratings, so you need to read it carefully to understand exactly what that specific design is covering. And most UL designs are intended for a particular manufacturer. Not always. There are a lot of designs that do include multiple manufacturers. The UL designs are not interchangeable between products unless specifically noted in the design. You can't take desirable features from one design, combine it with desirable features to another design, come up with your hybrid. That sort of process is not allowed. You're required to use those designs as published. And there are a number of modifications that are permitted by the guide information. Those are permitted. And the classic example I always give in that particular case is, and perhaps doesn't pertain to your industry, but for example, if you're looking at a design that covers a gypsum board wood stud wall assembly, and the design says the wall is to be constructed of 2x4s, can you construct it with 2x6s? Well, by the design, the answer is no. But if you go over to the guide information, it will state that the stud size is specified in the design is a minimum, and anything larger can be used. So that's a classic example of how the guide information can be used to modify the specific requirements of an individual design. And of course, those designs are published under the UL Product IQ online directory, accessible through www.ul.com/PIQ. And Kevin will be talking more about that in a couple of minutes. And then the individual product categories describe some generic family of products, for example, intumescent fire-resistant materials. And then within that product category, we will have some guide information which pertains to the use of intumescent fire-resistant materials. And then it will cover the individual manufacturers who produce products that are certified by UL for use in these designs. And each product category will contain the name of the manufacturers and the designations of the products have been tested, and then either the designs that those products can be used with, or some parameters by which that product can be used in conjunction with the designs. So a couple different formats there depending on the specific product category. So at this point in time, I'm going to turn the slides over to Kevin, and Kevin can talk about accessing UL product IQ rather. So go ahead, Kevin, you can take over from here.
Okay, thank you, Rich. Hello, everybody. My name is Kevin Highland. I've been with UL Solutions for 25 years. And thank you, Bill, for having me. As Bill mentioned, I took on the role of principal engineer about 2 years ago. So I'm happy to be here. Thank you for inviting me, and thanks for listening as we go through the wonderful BXUV guide information. Okay, so where can you find it? It's on UL Product IQ, which is basically UL's online certification directory. We no longer publish the directories in book form. They have not been published since 2016. So if you have anything printed, please don't look at that. You can use it as maybe a backup reference, but since 2016, there's been many changes. So please use Product IQ. So how do you get there? You can go to our main page, www.ul.com. And there, with the arrow shows in the lower left, find a product certification. You can click there, and then that'll take you on the next slide to the login page. So if you're not already a member, you do have to register. It's a one-time registration. It's free for use. Once you click that link, you fill out your name, email, stuff like that. And then like a few minutes later, it says it will email you back an authorization link to get into Product IQ. So it is for free, but you do have to register. And as Rich mentioned, another way to get here directly is that link at the top there, ul.com/PIQ. So next slide. Yeah, and if you're already registered, you just log in. So once you're logged in, this is the screen that you'll see here. This is like the main search bar. It's very powerful. You can type stuff in and it kind of tries to guess what you're trying to look for. But what we're looking at today is the BXUV guide. So you just type BXUV space guide, and the letters, we get asked quite a bit, what do the letters BXUV stand for? They don't stand for anything. As Rich said, it's just a 4-letter way to just differentiate everything. It was probably created in the 60s or 70s here. We haven't changed that, but that they don't mean anything. So just type in BXUV guide and hit enter, and then on the next page, this is what you should come up with. The BXUV guide info will be right there at the top. So where that arrow is, you would click that link. And the next slide, yeah, here, this is what you'll see, the BXUV guide info. This is the most looked at thing on Product IQ. On all of Product IQ, this is the most looked at thing. I liken this to sort of like not quite a building code, but it's, as Rich described it, you have to work, you can sometimes work with this BXUV guide and the designs to know what variations you can make or cannot make. It is the most looked at thing. If you pasted this into a Word document, it's 50 pages of text, so it's quite a bit of text. So next slide, please.
And maybe, Kevin, can I introduce one other comment?
Sure, go ahead.
The very first item of BXUV guide is a table of contents of what is contained here. And these are links. So if you just click on any of those topics, it will take you directly to the page of the BXUV guide that discusses that particular topic. So it's a very useful tool for getting to what you specifically need. Otherwise, if you're trying to page through 50 pages of information, you would find it very difficult to find what you're looking for. Okay, go ahead, Kevin.
Yep. And yeah, so there's 6 kind of main topics in the BXUV guide, one being introduction, 2 general stuff that applies to every type of assembly, whether it's a floor, beam, column, or wall, that would be in general. And then topics that or information that's specific to certain assemblies would be found under those assemblies, section 3, 4, 5, or 6. You go to the next slide. So in section 1, there is a table that breaks down, gives letters and the numbers. It gives an explanation of the design numbers, such as like a wall design like U305. It tells you what those letters and numbers mean. Most or nearly all the designs in the directory consist of 4 digits, the first digit being a letter, and then the next 3 of those 4 digits being a number. That letter identifies the type of construction, whether that letter's A, D, G, whatever, that letter identifies the type of construction like floor, wall, column. The last 3 digits describe the type of protection like plaster or gypsum or SFRM. So most of the designs are 4 digits with one exception. Columns that are tested to the rapid rise petrochemical fire exposure include the letter R for rapid rise after the alpha character. So X is for column and R is for rapid rise. So a design that starts with XR would be a column that has been tested to the rapid rise curve. You don't need to memorize this. There is a table there in the BXUV guide that explains this. And even if that's confusing, the powerful search tools with Product IQ, you don't need to really know what these letters and numbers are, because the Product IQ search tools, you can type in, hey, I want to find a wall that has gypsum board. You don't need to know that those start with the letter U and then the 300s. You don't need to know that because of Product IQ. But this table is there to explain what all that means. Next slide, please. Okay, and as I mentioned, each of those letters signify what type of assembly it is. So an N, if the design starts with the letter N, that's a beam for a floor. If it's a wall, it would start with the letter U, V, or W, and so on. Next slide, please. And as I mentioned, those last, the first character is the letter, and then the next 3 characters is numerical. There's 3 numbers. So if it's U300, actually, if it's a 600 series, it would be an intumescent coating. 700 or 800 series, it would be an SFRM. And the 900 series means it's an unprotected assembly. So those last 3 characters, the numbers refer to what is the protection material.
Yeah,
next
and
slide.
When Kevin says the 800 series, that really means design number 801 through 899. So it's a
Correct.
series of designs.
Correct, thank you, Rich. So here's some examples spelled out. D700, that D refers to a floor, 700 refers to an SFRM. P800, P refers to a roof assembly, and the 800, again, also refers to an SFRM. And then the last example here, X600, the X refers to a column, and the 600 series, 601 through 699, means it's an intumescent fireproofing, intumescent fire resistive coating. So go to the next slide. Okay, Rich, back to you.
Okay, great. Thank you, Kevin. Great job. So I'm going to continue talking about the information in the guide. And this particular piece of information is found in section Roman numeral 1, which was that general information, I'm sorry, the introductory information rather, and then the 2 refers to the fact it's a second item or second paragraph within that introductory information. So you can always reference the pieces of information in the guide based on that table that Kevin showed you earlier. So in reality, there's a number of definitions in the guide information that pertains to fire resistance, and 4 of those are particularly important to your industry: building units, direct applied protection, prefabricated building columns, and unprotected assemblies. So let's look at those definitions. Building unit is simply a particular type of product covered by a product category called building units, and typically it's some sort of a manufactured composite type of a panel product providing some sort of a fire resistance rating. And then direct applied protection, folks are probably very familiar with that, but it describes various types of fire resistant materials, including sprayed, intumescent, mastic, subliming type materials applied directly to the construction. For example, directly to the bottom of the steel deck, directly to the beams, etc. So that's the key. They're directly applied to the structure itself. And then we have prefabricated building columns, and those are structural building columns that include a fire resistant protection system when delivered to the construction site. And for years, UL's had a couple designs that show a concrete encased column with a light gauge steel wrapping around it. And I never had known too much about those products. They existed when I came into the fire resistance group at UL in 1987, but I actually ran across the manufacturer of those products recently, and they're out there in the field actively promoting that type of construction. So anyway, those are prefabricated building columns. And then we have an unprotected fire resistive assembly. Now, that is perhaps a bit of a misnomer, because obviously we need some sort of protection on these assemblies in order to achieve the rating. So what that's really referring to is assemblies where there is no direct applied coating or suspended ceilings to protect the general floor area or roof areas of that assembly. Even though it's referred to as an unprotected assembly, typically those assemblies will have some sort of protection applied to the structural elements, to the beams, joists, and so on and so forth. In most cases, some sort of a direct applied material. But bottom line is that unprotected refers to the protection on the deck itself. And now moving on to section 2, or Roman numeral 2, that covers general information that's applicable to all of the various designs. And there's several pieces of information that would be important to you folks. One of them is reference to interior and exterior applications. And then the next would be information about the coating materials, both the spray applied fire resistant materials and intumescent fire resistant materials. Now, UL refers to the sprayed materials as spray applied fire resistant materials. So your industry uses the phrase typically sprayed fire resistant materials. And Bill and I were also successful in getting ICC's International Building Code updated to reference these as sprayed fire resistant materials. So now Bill and I are working with Kevin to get the UL listings updated to also use that industry terminology of sprayed fire resistant materials. So that will happen at some point in the future. So anyway, so let's look at the interior and exterior applications. Again, that's covered under Roman numeral 2, general, and then item number 5 under Roman numeral 2. So basically what this says is the fire resistant designs and certified materials are investigated with the understanding their use is limited to interior applications unless otherwise specified in the design or certification information. And typically the form that reference will follow is the phrase investigated for exterior use in conjunction with the description of the specific product that was used to provide the protection. So list the manufacturer, the designation of the product, along with that phrase investigated for exterior use. What that implies is that UL has done a series of tests to evaluate that material will still provide its fire resistant performance after exposed to various elements that would be anticipated in an exterior application. The UL guide information also at one point in time used to contain a phrase, or unless otherwise obvious. For example, if you're looking at a column, I'm sorry, let's say we're looking at a wall assembly or a roof assembly, and that wall assembly contains exterior siding products on the exterior side of that wall. Is that design acceptable for use as an exterior wall? Realistically, the answer is yes. Otherwise, it wouldn't reference the exterior siding, for example. So same thing with a roof. Is a roof intended for exterior exposure? Well, obviously, by its nature, it is. That phrase was removed a few years ago. In any case, but I think that same general rule still applies. If it's a roof assembly, of course, it's intended for exterior applications. The materials used to protect the roof may not be, but the overall assembly certainly is an exterior assembly. And then there's another phrase in the UL guide information talks about is where an exterior application of the UL certified design is desired, code authority should be consulted to ensure compliance with other requirements applicable to exterior use. For example, if you have an exterior wall, NFCA 285 is a flammability evaluation for that exterior wall. Likewise, a roof assembly is required to be subjected to UL 790 and exterior fire exposure on the roofing systems. So this is just a reminder, don't forget about those requirements also. So next item we'll want to talk about is covered under Roman numeral 2, general, item number 8, and that covers coating materials, your typical spray applied fire resistant materials and intumescent fire resistant materials. And one of the big topics under that section is how do we address the situation where you have an unknown primer applied to the structural steel. So the question has always been, will the sprayed fire resistant materials adhere to that unknown primer? And this was a huge deal when I first came into the UL Fire Resistance Group in 1987, and the industry was struggling on how to address this issue. So UL hosted a series of task group meetings with the manufacturers of the sprayed fire resistant materials, along with the manufacturers of the coating materials, and put together the thought processes and did a little bit of research, and ultimately came up with a series of guidelines on how do we address that situation where, as a contractor, you show up in the field and you find that the steel is primed. You have no idea what that primer is. You have no idea whether your sprayed material you're going to be using will adhere to that primer. So you scratch your head like this gentleman's doing and say, now what do I do? What do you do when that prime steel is oversized? What if you fail a bond strength test? There's a whole series of rules and requirements that come into play here, which I'll explain here as we go along. But one of the requirements says that if the material, if the size of the structural element is small, relatively speaking, then the material itself will adhere to itself and have enough cohesion strength that it will stay in place even if it loses some of its bond strength adherence to the steel. So the requirements really relate to what is the size of the structural steel elements. And for a beam, the limitation is the flange width shall not exceed 12 inches. For a column, that flange width shall not exceed 16 inches. And then for a column or a beam, the web depth shall not exceed 16 inches. And then if you're, and there's an added bond strength requirement also, but we'll get to that one in a minute. But if your size of the steel members are larger than those dimensions I just gave you, then it's required that the structural element be protected, or there be strips of lath or studs and discs applied to the structural member for a minimum of 25% of the size of the oversized flange or web, and that lath width shall not be less than 2.5 inches, and that lath needs to be welded, screwed, or powder actuated fasteners on minimum 12-inch center to the structural element. So basically, you're providing a mechanical brake within that oversized dimension to provide some adherence for the sprayed fire resistant materials. And if you have a tube, steel, or pipe, the dimensions would be for a tube width that does not exceed 12 inches, and then the pipe outer diameter does not exceed 12 inches. What happens if it does exceed those dimensions? Well, then you need to apply again the lath or the studs and discs to provide that mechanical adherence of the fireproofing material to the structural elements. And once again, the width of that lath strip shall be no less than 3.5 inches, and the clear span of the pipe shall not, or tube shall not exceed 12 inches. So here's a photo of an application of lath. In this particular case, this beam was oversized, and as such, lath was required. Strips of lath have been applied to the web section, and that provides adherence for the fireproofing. Now, the second requirement to use hand in hand with those dimensions that we've just gone over is a bond strength test. If you have that unknown primer, you need to conduct bond strength tests of the spray applied material as applied to that primed steel. And the results of testing in accordance with ASTM E736 should indicate a minimum average bond strength of 80% and a minimum individual bond strength of 50% when compared to the bond strength of that same material applied to a clean, uncoated 1/8-inch thick steel plate. In other words, a control sample. And the average and minimum bond strength value shall be determined based upon a minimum of 5 bond strength tests. Now, if you do not meet your bond strength requirements of 50% and 80%, then you can use a bonding agent to meet that requirement. If you meet the strength requirements with the bonding agent, then you're good to go. If it's not met, even with that bonding agent, then you need to provide a mechanical bond by wrapping the entire outside perimeter of the structural element with an expanded metal lath. And the guide information will give you more details on how to do that, the specifications on the metal lath, and so on and so forth. So at this point in time, I'm going to turn the floor over to Kevin, and Kevin is going to talk about intumescent fire-resistant materials. So go ahead,
Okay.
Kevin.
All right. Thanks, Rich. You can go to the next slide.
Okay.
So there it talks about thickness, how to measure the thickness, determine the right thickness is on the column or beam, the structural member in the field. When we test columns and beams in the lab, maybe on like a 9-foot column or a 13-foot long beam, we take maybe 80 or 100 readings here in the lab to ensure that that coating thickness is uniform, so we know what we're testing. But do you have to measure it that many times in the field? No. So the BXUV guide says the thickness that's in those designs, the column design or the beam design, use the AWCI Technical Manual 12B, standard practice of the testing and inspection of field applied thin film intumescent fire resistant materials. In there, there's a method, I think it's based on like the total square area at the job site, how many readings to take. So that's what the guide information says is the thickness that's published in the design. Use the AWCI manual, how many readings to take at the actual job site to ensure that the right thickness of intumescent material is on the column or beam. Another important point with intumescent materials, the guide says you cannot extrapolate the element size, the beam or column size, or the material thickness. Next slide, please. Okay, and part of the reason for that last statement and then this next one up here is with intumescent coatings, how they perform. They form when those thin paint coatings see fire, see heat at a certain temperature, the coating starts to expand and form a char, an insulating char, and that's what protects the steel beam, the steel column. It insulates it from the fire, keeps the steel temperatures low up to a certain point. But what can happen with intumescent coatings, you might think, oh, the more material I put on, the better. Well, some coatings might have a limitation that if you put more of the material on than what is tested, that might actually be bad, because if that char gets too big or too much, gravity then might come in and actually start to pull that off, and actually you might have a lower rating than what what you originally had with that lesser thickness. So that's why that previous statement says do not extrapolate the thicknesses. And then here it says the average thickness should not exceed the maximum thickness published in the individual design. What that means is that the maximum thickness in that individual design is the maximum thickness that we have a test data point on, so do not exceed that. And then at the other end, you don't want to go too low, so it says no individual thickness measurement should be less than 80% of the thickness specified in the design. So you really need to be close to what the thickness is stated in the design. And of course, the material installed, you have to follow the installation instructions. Not everything is published in the design. The manufacturer does provide some instructions, how to mix, if it's a part A, part B, how to mix all that, what temperature it needs to be mixed at, etc. And then that last point here, I mentioned that in order for it to work, the intumescent material needs to expand. So the guide says the clearance required around the protected element, the column or the beam, clearance is required around the protected element to allow for free expansion, and contact the manufacturer for that recommendation. So in other words, you might think, hey, I have a column here, maybe there's a lot of traffic in the area, so I want to put some kind of steel plating around it so it doesn't get bump damage. That's a good concern to have. But if you do that over an intumescent coating, you're leaving no room for it to do its job to expand. So that clearance is important. Next slide, please. Okay, next, section 2.9 talks about gypsum board. Gypsum board is also a very good fire-resistant material when it's used on wood or structural steel members and it's exposed to fire. There's chemically, water is in the gypsum board in a chemical crystal form that when the fire or heat hits that gypsum board, the fire and heat first go to driving that water out as steam. So then the gypsum board acts as a thermal barrier until that process, that it's called calcination, until that process is completed. Next slide.
Kevin, before you
go ahead.
jump in, I'll just say that I once did some calculations, just a little piece of trivia. Each 4x8 sheet of 5/8 inch thick gypsum board contains 1.86 gallons of chemically bound water. Hard to imagine, but that's what the numbers work out to be. Go ahead, Kevin.
How long did it take you to do that calc, Rich?
30 seconds.
Really? Okay, cool. All right. Okay. So there's kind of like two general types of gypsum board, type X and type C. We'll first talk about type X. It was introduced in the 1950s. What does type X mean? Where is that defined? That's defined in an ASTM standard C1396. And one of the definitions for type X says that if you take 2x4 wood studs and put one layer of 5/8 gypsum board on either side of that wood stud, there's a certain nail pattern, certain type of nail, and you subject that to the UL 263 ASTM E119 fire test, and if that achieves a 1 hour rating, then that 5/8 board can be called type X. Its primary use is in walls, used in 1 through 4 layers. It is in some ceiling designs, but typically you cannot put insulation on top or on the back of the gypsum board in the ceiling plenum, because under fire conditions, the heat buildup, the heat's on the underside of that ceiling, that insulation that's on, if you have that on top of the board, that's kind of trapping the heat there, and it will accelerate that calcination process, that degradation process. So there's some limitations to the performance of type X boards. All right, next slide. All right, thank you. And then the other type is type C gypsum board. That's not really defined anywhere in the ASTM. Maybe someday it will, but it was first introduced by USG in the early 1960s, and then later on in the 1980s, other manufacturers started making their own version of a Type C board. What makes it different than Type X board is Type C boards contain a special core formulation that compensates for the shrinkage, that calcination that we're talking about. There's some special ingredients there that make up for that to reduce the effects of shrinkage. This board has become the norm for many column, beam, roof, and floor ceiling assemblies. What you just have to do is look in each design, and it will state the manufacturer and type of board, type designation, model name of the board allowed in that design. A very common misapplication of this is if the design calls for a Type C board and a Type X board is actually used. That would not be allowed unless that Type X board is specified in the design. And the reason for that is, as we showing on the screen here, the Type C boards tend to perform better because of that different core formulation, different weight. So if Type C board is the only type specified in the design, that is the one that you have to use. Okay, next slide. Okay, and then maybe the last thing in this section, general, I think Rich mentioned this earlier. This is stated at the very top of the BXUV guide. Fire resistance ratings apply only to assemblies in their entirety. You're not really allowed, other than beam substitution, which Rich will talk about in a bit. Other than that, you can't look at one design and move something, from that design over to another. Another thing, what this means is that no specific material in the design has a rating. Like there's really no such thing as 1 hour rated gypsum board or 1 hour rated plaster or a fire rated nail. Although those things might be tested in a fire resistance assembly, and are a part of that, the rating applies only to the assembly, not the individual materials. Okay, next slide. Okay, so let's move on to section 3 for floor and roof ceilings. This has 24 subsections, and we'll talk about 4 of those. You can go to the next one, Rich. Okay, so those 4 we'll hit on today is concrete, steel floor and form units or steel deck, steel joists, and the deep end of the pool, restrained and unrestrained assemblies. Next slide, Rich. Okay, what the BXUV guide talks about concrete, section 3.1, it makes a general reference that there's 2 types of concrete in all the designs, normal weight and lightweight concrete, kind of defined by the densities there, normal weight having the higher density, lightweight having a density there 90 to 120 pounds per cubic foot. So each design will state a minimum compressive strength, and generally that's the compressive strength of the concrete that was used in that fire test. And there is some data to show that the compressive strength is somewhat tied to the hourly rating. So that's why it's specified there. But the BXUV guide does allow a little bit of tolerance there. It says you can reduce that concrete compressive strength that's specified in the design by 500 PSI to obtain the minimum value. Also, the density, the dry unit density of the concrete is also specified in the design. Again, that's linked with the fire resistance rating thermally, and the BXUV guide. Sometimes the design might just have, the engineer might have just put like a number in there as a density, and what the BXUV guide is saying, that number has a tolerance of 3 PCF unless the design states otherwise. And then the last thing is key. If sometimes the design will have normal weight and lightweight concrete and specify different, what thickness is needed for either one. But if the design only has lightweight concrete, you cannot just interchange that with normal weight concrete because they behave differently. Normal weight concrete acts in a fire test, acts as a heat sink, kind of absorbs the heat, and lightweight concrete in a test tends to reflect the heat. So if this concrete is on top of a beam, that will cause the temperatures on the top flange of that beam to react differently depending on which type is there. So when lightweight concrete is specified, the use of normal weight is not allowed, and also vice versa. If normal weight concrete is the only one specified, you cannot use lightweight concrete. All right, so that's concrete. Next slide, Rich. All right, steel floor and form units are just steel deck. Key thing here is that the type of unit and the minimum steel thickness are specified in each design. So there's quite a few different types of deck. There's roof deck, there's corrugated deck, fluted deck, cellular deck. Again, all those can have, if the design calls for fluted deck, but hey, the builder wants to use cellular deck, there's some implications with that. Again, with that top flange of that beam, when you have cellular deck, then there's no access to that top flange to protect that. So will that heat up faster? So you have to pay attention to the design, and whatever type of deck is called out, you have to use that. All right, next slide, Rich. This is
Not sure why that's not advancing.
Okay, the next one should be steel joists.
There we go.
Okay, yeah, section 3.7 is about steel joists. Some designs will call out a specific type, like a 10K1 joist. That would be the minimum size, but other designs give a minimum depth and a minimum weight per foot. So what this is saying here is then that is considered the minimum size. You can use that size or anything larger when you consider both the depth and the minimum weight per foot. That's based on like the mass of the steel, which we'll get into in a little bit. Also with steel joists, for designs that require the bottom chords of the joist to consist of round bars, the substitution of angles of an equivalent area is not recommended. I think the reason for that is that bottom chord might be the one seeing the most stress, because these tests are loaded. The standard says, hey, you have to build these full scale and subject them to a load if it's a load bearing assembly. So anything with the joist is a load bearing assembly. And so when you load that, that stress, I think, is mostly picked up by that bottom chord. So that's why this sentence or that statement is there, that you can't substitute that. And then also when the design calls for bridging bars or angles for the joists, and those joists are have SFRM on them. If those joists are protected, you also have to put that protection material on those bridging bars and angles 12 inches beyond the joist. Next slide, Rich. Okay, hey, restrained and unrestrained ratings. All right, the deep end of the fire resistance pool. So the guide information says that it's up to the designer and the code authority to determine if the assembly is restrained or unrestrained. So each design has restrained and unrestrained thicknesses in them in general, and it's tied to certain ratings. So what's to decide whether which one you use, restrained or unrestrained? The BXUV guide says it's up to the designer or the code authority to determine if the assembly in the field is restrained or unrestrained. If that's unknown or undetermined, the BXUV guide also says the unrestrained assembly ratings, because those conditions are more onerous. The unrestrained assembly rating may be used for either the restrained or unrestrained condition. Next slide, please.
Kevin, let me add one more point too. The International Building Code also has requirements for the decision on restrained versus unrestrained. Excuse me. And the code basically says that unrestrained ratings are to be utilized unless satisfactory information is provided to the code authority to demonstrate that the assembly qualifies for a restrained rating in accordance with ASME 119 or UL 263. So that puts the responsibility on a design professional to provide the guidance or not provide the evidence to the code official that the assembly is in fact restrained or not.
Okay, and to determine that, there's generally two ways to do that. The first one there says that the structural engineer, the engineer of record, can calculate the relative stiffness of the surrounding structure and compare that to the stiffness of the UL test frame. That's the concrete and steel frames that we have here in our lab that floors and beams are tested in. So someone years ago did a calculation on these test frames. They're all built the same way. I think we've had them since the 50s and 60s, the same ones. We published that as a point of comparison. So that number is in, the stiffness numbers are in the BXUV guide. So if that calculated thickness is greater than the stiffness of the UL test frame, that can be considered restrained. But if that calculated thickness, stiffness is less than that, those numbers in the BXUV guide, it is considered unrestrained. That's the first way. The other way is in UL 263 and ASTM E119 and also the BXUV guide, they all contain pretty much the same table that has given construction parameters, conditions for floors, for beams, etc. And if you follow there, if you look up what type of construction you have or what situation you have, what's the surrounding structure, it'll tell you if that is restrained or unrestrained. A side note on that, there is an ASTM E119 task group formed recently to look at making some modifications to that table to make that more clear, more helpful, more useful. So we might see a little bit of adjustments to that in the future. All right, Rich, I think this is over to you.
Okay, great. Thank you, Kevin. And so I'm going to talk about the differentiation between beam ratings versus assembly ratings. And UL does publish two series of beam designs, beams intended for floor applications and beams intended for roof applications. And there's two purposes of those designs, the N series for floors, S series for roofs. And the first application is where the code only requires a rating on the structural member. And certainly there are applications where that is the case, or sometimes there's applications where the code has a longer rating requirement for the beams and joists as compared to the rating of the overall assembly. And in that case, we can use the beam designs to replace the beam that is specified in the fire resistance rated floor ceiling or roof ceiling. For example, if you have a 2-hour assembly rating in that floor ceiling or roof ceiling design, and the code says we need a 3-hour beam with a 2-hour floor rating, we can replace that beam specified in the floor ceiling or roof ceiling assembly with a beam only design that has a 3-hour rating. So there's some rules and methods by which we can make those substitutions. We need to follow those rules very carefully. And they're another one of those difficult concepts perhaps to follow, like restrained versus unrestrained. But in any case, I'll give you some of the guidance on how to make that substitution. And the guide information also says beams need to be defined based on the WM or S-shaped structural steel as defined by AISC. And section 4, the guide information, item 1, talks about the minimum beam size is always defined by W/D ratio. And basically, W/D defines the massivity of that piece of steel. In other words, how much weight it has per unit length based on the heated perimeter. W is the weight, D is that heated perimeter factor. So each size beam has, or column for that matter, also has a specific W/D number associated with it. Now, when you're using beams in conjunction with steel deck floor assemblies, then you have that cavity that is created above the top flange of the beam and beneath the steel deck, that trapezoidal shaped cavity, and that needs to be protected in some way, shape, or form, and it basically protected in one of two ways, either based on their use of the sprayed fire resistant material that's being applied to the beam and or the deck, or you can use that same fire-resistant materials in conjunction with the mineral wool. And the guide gives a couple different ways by which to do that. So the flange width is less than 8 inches. You fill the entire width of the flange with either spray applied material or spray applied material in conjunction with mineral wool. If the flange width is greater than 8 inches, then you can protect it for a depth of 4 inches from each of the two sides of that beam. So that's covered in detail in the guide information. And then we have those beam substitution procedures, which I talked about before. And again, the N series designs cover beams only, and those beams are intended for use with floor assemblies. Those floor beams can be substituted into the specific A, D, G, or J series floor ceiling assemblies, subject to a very specific set of rules. And overall, one of those rules is the beam rating of the N series design must be equal to or greater than the assembly rating of the floor ceiling assembly. Obviously, if the floor ceiling assembly is rated for 3 hours, the beam is rated for 2 hours, it's not going to work. The beam is going to lose its structural integrity, causing the overall assembly to lose its structural integrity also. So the beam rating always has to be equal or greater than the assembly rating. Likewise, if you're dealing with roof assemblies, you can substitute an S series design for the specific beam covered in the P series roof ceiling designs. Again, subject to that rule where the rating of the N series beam must be equal, or I'm sorry, S series beams should be equal or greater than the assembly rating of the roof assembly. And continuing on, the substitution really relates to the type of roof or floor being supported, the amount of fireproofing or protection on the floor or roof units, and the type of material applied to the beam. And all ratings are specific to the manufacturer and the fireproofing materials. So the UL guide information has some requirements for that beam substitution. And one of the requirements is the substitution of beams into a floor or roof assembly should be limited to assemblies which have a similar or greater capacity for heat dissipation from the beam as compared to the capacity of the design from which the beam is transferred. In other words, you need to have more heat capacity in the assembly as compared to the beam only design. And the idea behind that is, the concrete acts as a heat sink. It keeps the top flange of the beam cooler. So the more concrete you have, the better that beam is going to perform and the longer its rating is going to be. So you're limited to substituting that beam only design into assemblies which have a greater or equal capacity for heat dissipation. And I'm calling this a beam substitution rule, but in reality, that rule applies to not only beams, but also joists and trusses. And again, less concrete on the top of that flange means the flange gets hotter quicker, and as such, then the beam would require more fireproofing material to reach a particular rating period. So here's a series of graphical representations of how we can make those substitutions. And this information comes directly from the NFCA Handbook of Fireproofing Knowledge. That manual has a very detailed description of the processes that I am describing now. These illustrations are coming from that document. So after the webinar, if you want to get more details, strongly suggest you go to the handbook and review that in more detail. It'll provide more information than we can provide in a 1-hour webinar. So let's look at those substitutions. So on the left-hand column, I have the full construction assembly. In other words, the P design, the floor assembly is either an A, D, G, or J series. And on the right, we have those partial construction beam only designs. The handbook calls these things partial constructions. UL calls them beam only designs, but they're all one and the same. So the first item, can you substitute an S series beam only design into a P series roof assembly? The answer is yes, you can. Can you substitute an N series design into an A, D, G, or J series floor ceiling assembly? Yes, likewise you can. Can you take a beam from a P-series overall assembly rating, substitute it and create an S-series design? No, that wouldn't be appropriate, nor would it realistically ever be necessary. Likewise, for the floor beams, you can't create a floor beam design based on your floor assembly rating. And likewise, another series of rules. Can you use a partial constructed beam only roof design, beam only design in a floor assembly? The answer is yes. Now that may be counterintuitive, you're substituting a roof design into a floor assembly, but in reality, it goes back to that rule of, do we have equal or greater heat capacity for heat dissipation in the assembly you're substituting into? If you have a roof assembly, those beams are typically tested with some sort of roof insulation, for example. Can that be used in a concrete floor assembly? Yes, because the floor has more capacity for that heat dissipation. Can you substitute a floor beam into a roof assembly? The answer is no, for the opposite of what I just explained. The roof has less capacity for heat dissipation, so that substitution could not be made. So now let's address the question of protected deck versus an unprotected deck in terms of how it relates to this beam substitution rules. A protected deck assembly may be substituted by a protected beam design. In other words, you can take a beam design that was tested with a protected deck and substitute it into a protected deck assembly. Likewise, if you have an unprotected deck beam only design, you can substitute that into an unprotected deck assembly. Next scenario, if you have an unprotected deck beam, you can substitute that into a protected deck assembly. And the reason for that is that protection on the deck is going to minimize the heat transfer from the deck into the top flange of the beam. So that substitution would be acceptable. And then likewise, you can substitute a protected deck beam only design into an unprotected deck assembly. Let's see. But if you do that, you need to protect the deck for a distance of 12 inches away from each side of the beam to the same thickness as required by the beam. In other words, going back to that heat transfer concept, if you have tested the beam with a protected deck, if you substitute it in an unprotected deck, in theory, you have heat transfer from the deck into the top flange of the beam, so that substitution would not be appropriate. Therefore, the requirement is in place that if you need to do that for whatever reason, you can do it, but you need to protect the deck for a distance of 12 inches from either side of the beam. Here's again a series of graphical representations of that concept. These come out of the handbook. So again, I'll encourage you to go to the handbook and read about this in more detail. Yes, you can substitute a protected deck beam only design into a protected deck assembly. You can protect or substitute an unprotected deck beam design into an unprotected assembly rating. And you can go from an unprotected deck to a protected deck. You can go from a protected deck to an unprotected deck, but only if you do that 12-inch spray out on either side of the beam assembly.
Rich, I think we need to get those arrows and pictures into the guide instead of the text. I think that explains things a little easier, right?
I would absolutely agree with that, Kevin. Be happy to help you do that.
Okay. All right, so we're at the home. Go ahead.
I was just going to say, and I don't know if it's come out before, but Kevin has responsibility for the information in the guide information. So, the association needs to work with Kevin to get suggested changes into that guide, and Kevin is very receptive to doing that. So, we'll work together to get those illustrations into the guide. So, I guess at this point, do you want to take over from here and talk about this?
Yeah, sure. We're at the home stretch here. We're going to talk about thickness, shape factor, W over D, and then some thickness adjustment rules. So in talking about thickness of like a spray-on coating, whether that's an intumescent or SFRM or maybe some other material, that's specified in the design. And so that thickness depends on a few things: the fire resistance rating, the hourly rating, whether that's 30 minutes, 1 hour, 2 hours, 4 hours. It depends on the shape factor of the steel section, W over D or A over P. We'll look at that in a second, what those are. That's basically just how big or massive is the steel section. Also the type of steel section, whether that's a I shape, W shape, or a hollow section, like a hollow tube or hollow pipe. How many faces of the steel section are exposed to the fire. For a column, there's all 4 sides. That's what the fire test says. You've exposed all 4 sides of the column to the test. In a beam, there's usually a floor section on top, as Rich was talking about earlier. So only 3 sides of the beam are exposed. And as we've talked about over here, when you have a beam, there's things like concrete, steel deck on top of it, or if it's a roof assembly, maybe there's some foam plastic on top of that, so the construction being supported. And then the properties of the fire-resistant material itself. Some, like intumescent coatings, are proprietary. Some behave differently. So that all these things on the screen here relate to the thickness. So this is why when someone might say, well, how come it's not the same thickness for everybody? You know, I want the same rating, I have the same beam size. Well, I want 2 hours. How come it's not the same for these 2 manufacturers? Well, their materials might be different. Next slide, please. Okay, so for wide flange steel, I mentioned like massivity, like how big the steel is thermally. That's the shape factor, W over D. That's the weight of the steel, I think per foot, over the heated perimeter. So I mentioned the fireproofing thickness is based on that, because the greater the W over D, the greater the mass of steel, the longer that will take to heat up. And so the longer it takes to heat up, if you have a really big steel size, you might not need as much fireproofing thickness on that, because the steel is absorbing a lot of that heat. And so you don't need as much fireproofing thickness on that steel. And there's some adjustment formulas for SFRM, which we'll look at in a bit, for SFRM only. So that was for wide flange steel. For hollow steel, tubular steel, circular pipes or square tubes or rectangular tubes, the term is not W over D. In the Imperial, it's A over P. That's also the shape factor for tubular steel. The A is, you can calculate this with any tubular steel that you have. A, you calculate the cross-sectional area of the steel. So that's like your volume of steel divided by P, which is the heated perimeter. How much, what's the outside of that steel? So you divide those two, and then you come up with a number. Same thing with the W over D, you come up with the number. So these you can calculate on your own, and they're also published. AISC publishes, their book. There's pages in there that list all those W over Ds, and I think with A over P as well.
Yeah, and likewise, the W over D ratios are published in the International Building Code in section 722, calculated fire resistance. So those of your code officials, that's an easy way of getting to that information.
Okay, so then just to dive into it a little bit, with the wide flange section, we've said W over D, that's the shape factor, W over D ratio. The W over D refers to the weight per lineal foot. So here on the screen, there's a W 8x28 beam, a 12-inch long section, 1 foot long section, whatever that weighs, that would be the W. And then the D is that if you had like a string tape measure, something that you could just, a tape measure that you, like a string, you could conform to all around that I shape there, that would be the heated perimeter in inches, and you divide those two to get the W over D. So what does that mean? That's, the W over D, that's in all the column designs, the beam designs, it's in the BXUV guide. There's some thickness adjustment formulas that refer to W over D that we'll look at in a second here. Like why is that important? What does that mean? So there's two columns or beams on the, or I guess we call these columns here, 2 on the screen. One is a 8x28 and one is a W 14x22. Structurally, if you were to like load these, you know, which one is stronger structurally. I'd have to look up the maybe exact steel thicknesses, but I'm guessing probably the W14 by 22 would be stronger structurally. But which of these two is thermally larger when we're talking fire conditions? If you're not too familiar with the fire testing, how this all works, you might think, oh, like that larger column on the right, W14 by 22, you know, is that better under fire situations? Think of it this way: if you have your cup of coffee in the morning and you pour your coffee into a mug, you know, there's a certain amount of time that coffee will stay hot. But if you pour the same amount of coffee onto like a huge dinner plate, you know, with all that surface area, and that, you know, that layer of coffee is now thin, you're exposing that coffee to the air, and that's going to cool off a lot faster than the coffee that's sitting here. So that equation that's on the screen there to determine or calculate W over D, the bottom of that 4A plus 2B minus 2C, that is how to calculate the perimeter, the heated perimeter there. So if your heated perimeter, the one on the right, that's definitely larger. So that steel is, more of that steel is being exposed to fire all at once. So that will heat up faster than the one on the left. So that column on the right might need more protection material than the one on the left. So you can't think of things just there's cold conditions and then there's fire conditions. All right, next slide. Okay, whoops, yeah, there's the answers there. WD of the 8 by 28 is 0.68, and the WD of the 14 by 22 column is 0.47. So the larger the number in terms of W over D, that means it's has more thermal mass to it. So like I said, these numbers are all throughout the directory, throughout all the designs. They'll specify what that minimum W over D or A over P is, and any size steel with larger W over D or A over P may be substituted. I think that should say substituted with that same thickness. So it'll there's three ways that the W over D and A over P ratios are used. That first one, it'll specify what that minimum is. Some designs have an equation, make it really simple. The design is short and sweet. It'll say the equation will have hourly rating, thickness of the material, and the W over D. And then the user has to plug in your hourly rating and your steel size per W over D, and then it'll tell you how much thickness is needed on that. So that's the equation. And then the third way, you might have a design that's pages and pages long, because it'll just plug in all the numbers into the equation and just list out for every W over D, every hourly rating, what thickness is needed. That'll be in tabular form. Okay, next slide. So I mentioned thickness adjustment equations. There's two of them for SFRM. One is for beams and the other is for columns. The one for beams is shown here. So the material thickness on beams with a lesser W over D than specified in the design needs adjustment. And also thicknesses on beams with greater W over D may be adjusted with that equation there. So you have the W over D of the beam that's listed in the design and the one that you want to substitute, and the thickness that's listed in the design, and then you plug those things in and you get your T1, your adjusted thickness. And Rich, I think on the next one we have the one for columns. Oh, not yet. This is an example how to use that beam adjustment there, thickness adjustment equation. So if the design says the minimum beam size is W8 by 28, and that beam is supporting fluted deck, and it requires a 1/2 inch of protection on that beam to get a 2-hour restrained rating, but oops, your actual beam size is W10 by 49, what do? What thickness needs to go on that W10 by 49? You can use that equation we just looked at. I think we spell out the example on the next slide. Yeah, so you plug in there your W over D of the beam in the design, the 8 by 28, that's 0.68. The W over D of the beam that you want to substitute in, your 10 by 49, that's 1.02. And then that thickness that's specified for the 8 by 28 half inch, plug that into that equation there. You get a number 0.395, and then the guide there says you have to round up to the nearest 16th inch. So then that's 7/16 of an inch. So that's 16ths of an inch less. So you save a little bit of material cost because that W/10 or W10 by 49 is a larger piece of steel. And then lastly here's the thickness adjustment equation for SFRM's protecting columns. The material thickness on columns with lesser W/D than specified in the design, you can adjust it with this equation here. Same thing, the W/D in the design, the thickness in the design, and then your desired column to substitute. Punch that in and you get your adjusted thickness. And I think you have to round it up again to the nearest 16th. All right, Rich, you got the conclusion here?
Okay, just a very quick conclusion. Most UL designs are for particular manufacturer product. Not always. Some designs do include multiple manufacturers. UL designs are not interchangeable between products unless specifically noted in the design. Assemblies are listed in the UL Product on IQ online directory, accessible at www.ul.com PIQ. And those designs will detail the applications and installation procedures of the various materials involved. Those designs need to be followed as published, with the exception of the fact you can make certain substitutions based on the guide information. So the guide information works hand in hand with those individual designs. So at this point, we will take some questions. And I see there are a number of them.
Yeah, perfect there, Rich. Appreciate that. Let me pop on here. Let's see. First thing is the slide deck will be available at nfca-online.org probably later this week. So those of you who want to take a look at the slides, go right ahead there. I'm reading from the bottom up. As to bottom meaning the question came very recently. So first one is, you've already discussed let's see, a chance of discussing the conversion of WD to metric instead of inches.
I could be wrong. I think some of the designs have the metric there as well. It depends on just the manufacturer. They can, some just have the thicknesses, let's say just in inches. Some have, the tables where the thicknesses are in inches and then underneath it's in millimeters. And I think the same thing is with the shape factor. Just depends on the manufacturer. These are not really UL's designs. We'd like them, they'd be nice if they were all consistent and had all this information, but it is up to the manufacturer to tell us how they want their design or system to look.
Yeah, very true. They own the listing, so therefore they're the ones that edit the listing piece of it. You can deal with the guide information though. Yep. And does the guide information go metric, do both inches and metric, or is it currently just inches?
With respect to W/D?
Anything.
Maybe the question is with that formulation or with those thickness adjustment equations, those are just in W/D and they're not in the metric. Okay. That'd be something to consider. We could consider that.
Yeah, sounds like both of us, not just you guys, but the NFCA in its manual will have to do the same thing. Next question: does the grade of steel make any difference?
It does. Right in the BXUV guide, at least for beams, there's a statement there, if I can find it. It says also, unless otherwise stated, the load capacity of steel beams assumes the beams are fabricated from A36 steel. That's in the guide. So what it means, unless otherwise stated, it would be in the design heading if 50 KSI steel is allowed, but the guide does make a statement to that, yes.
Okay. Let's see. Question: person has trouble getting registered on ul.com. Who do they contact? I'm going to guess they contact first their IT department. If they don't have one, then they get a hold of your technical department.
Yeah, I read through the questions. I got to the page. There's a 800 or 877 number here, assuming that person's within the United States. It's 877-292-7279.
Okay, cool.
That's 877-292-7279. So hopefully that person who asked that got that. There's also a way to contact people, contact our support
Perfect.
online there.
Looks
That's
like
that's where Product IQ help. Product IQ,
okay.
login help. Yeah.
Fair enough. Looks like there's a couple of comments, questions, not really questions, about who approves designs, designer, code official, building official. Where's that responsibility lay?
I
think that question, Bill, looks like it was the restrained and unrestrained ratings.
Okay.
Who decides that?
Yeah, the ultimate decision is up to the code official. And again, the code says that the registered design professional needs to provide evidence satisfactory to the code official that the assembly qualifies for a restrained rating. So
Right.
It's the responsibility is to provide the evidence is for up to the architect or design professional. Ultimate approval, of course, always goes to the code official.
Right. Bingo. Let's see. Next question. So, what is one to do when a piece of steel that has a lower WD ratio of what has been tested when it comes to IFRM? In other words, it sounds like extrapolating. What do you do if I guess I would say fire test it.
Yeah, if it's not published in the design with IFRMs, there's currently no equations to go to a smaller WORD based on what we discussed. I would say contact the manufacturer. Maybe they have some other data, some other fire test data that's just not published.
Absolutely, good point.
And if you can't find the information you need in a particular design that you're dealing with, see if there's another design from that same manufacturer first that perhaps does cover that smaller section. And then if there's nothing from that manufacturer, maybe there's another manufacturer that has a design that covers the size of steel you need. And if neither of those work out, then yes, as Kevin says, contact the manufacturer. Nothing else, at least by doing so, you're logging it with their technical people that, hey, there's a need out in the field for testing these smaller sizes.
Fair enough. Next question came in: gypsum board joint treatment on when that's used for fire resistance rated assemblies. Now, you two know that there's different acceptance criteria for a wall versus a beam or a column or a horizontal assembly. So I'm not sure which one they're referring to. Let's just assume it's for the fireproofing side of things. It says joints taped and covered with one coat of joint compound. This person reads it that as tape set in the compound covered with one more layer of compound. The Gypsum Association has joints set in compound only referencing as one finishing. They also reference the GA 214 for fire rated assemblies needing only level 1. Is there a place in the UL listing where tape set in compound is only required for the fire rated assembly? And how does that work? Maybe just generically answer that one.
Yeah, I realize that the GA has the different finishing levels and the fire resistance designs, wall designs, ceiling designs. They've been around since the 50s and 60s. I think before those levels were established, but I'm in discussions with the GA. I think this is one item that we could look at to align the two things so that both are speaking the same language, that there's not different definitions of how joint compound goes on. In a ceiling assembly, that joint compound probably usually falls off within like 5, 10, 15 minutes into the test. But on a wall assembly on the fire side, that the same thing happens. It falls off somewhat early in the test, but on the non-fire side, it's there covering up those joints. So it is key. There is some importance to that. So I'd say I'll be work with the GA to get to have the both speaking the same terminology.
Very good. Keep us informed on that, because we might have to alter what we have in the manual. We don't have a lot right now in the handbook of fireproofing knowledge on gypsum wallboard treatment of beams and columns. But certainly that's a section we're going to be adding along with the wraps, endothermic wraps, and then other insulative materials that are used for that particular application. Next question is basically for Kevin. Said, why is it necessary to have an accountant login every time you access the UL designs? Some other agencies provide access without registration.
There is a way to look at this information without logging in, but that information is somewhat limited. So there is a way to access some of it without logging in, but to get the full design, you do have to log in. That question I would refer to somebody in our product IQ team to answer that.
Okay.
Yeah, I'll answer this, Kevin, for you. And I was involved in the development of Product IQ when I was with UL. I was the one interfacing with the computer folks, the IT people, in trying to make it happen, providing feedback. And you were involved in that too, weren't you, Kevin? So
Yep.
we provided the input of what the needs were. We didn't get everything we wanted, but bottom line is the reason for the registration to login is, quite honestly, is they are keeping metrics in terms of what pages are getting the most hits, who is making those inquiries. So they're mining that data in terms of how the system is being utilized. Now, the important takeaway though is that if you do not log out of Product IQ when you use it, when you go back to use it the next day, you don't have to log back in. So there is a registration process, but you don't have to log in and out each and every time. I haven't logged out of Product IQ for 2.5 years now.
Me too.
Yeah, likewise. Yes, Bill.
Okay, so next question: when thickness is calculated, no, let's move on to the next one because it's a statement. ASTM A992 is the standard for steel. Has UL Solutions updated things to reflect that? ASTM A992.
I'd have to look that one up, Bill.
Okay.
We're in discussions with the steel protection industry.
Okay.
Those things like steel, wood, concrete, we don't classify, we don't list those types of generic materials, even nails, staples,
Sure.
screws, steel studs, even some of them are called out generically. When those industries change, then this 80-year bank of test data, these designs, how do you change that? And that's one of the reasons of the BXUV guide, why it's, people ask what's its purpose, why is it so big? Instead of UL going into, all 2,000 designs to revise each one, let's say the nail designations change, to make it easier, we can put that into the BXUV guide and say, okay, there's maybe an alternate nail that was developed that's, similar in performance, and that we could put that in the BXUV guide rather than copying that into all 2,000 designs.
Yeah, next question is, does the failure temperature change with the grade of steel, especially when using high strength steel, E350 for beams? And if the next part of it is, how can we develop a lower thickness for the temperature changes from the 538 to higher? 538C is my guess.
Okay, I can say the second part of that is alternate temperatures. In UL 1709, 5th edition, first published 5 years ago, in the appendix there, annex, there's some methods for allowing the manufacturer to publish thicknesses based on different failure temperatures than the traditional failure temperatures in the standard. I think this is to do with a performance-based design. It lets the designer use different failure temperatures, whether they're lower or higher.
I see.
So that there is a way to do that. I'd say if you don't see that for a particular manufacturer or material, contact that manufacturer, and then maybe they should already have that data if it's a temperature lower, because we're running the test up to a certain failure point. Maybe they just didn't go through the exercise to have that developed.
Okay. The next question is, does commercial fireproofing, is the commercial fireproofing product, are, the many products that you have, are they tested with a hose stream test?
Okay, I was gonna say that was asked. I have a few of my colleagues on the phone. I was gonna say maybe that's a trick question they're throwing at me here, but it's not one of my colleagues. The hose stream test, I'm learning that's interesting. It's not in a lot of the European standards. In the North American standards, the hose stream test is only required. Now it's still only in wall tests for testing a wall. So it asks about commercial fireproofing, and the hose stream test that would only come into play if the fireproofing was in a wall assembly. There are like a handful of wall designs that have fireproofing, usually like in the inside and the wall, inside the wall cavity, as an insulation type material. So then it says there what pressure and duration. There's a table in the standards UL 263 ASTM E119 for, see, this is quizzing me, for ratings up to 1 to 3 hours, the pressure is 30 psi, and 4 hours and higher, the pressure is 45 psi, and then the duration is broken down based on the ratings. Ratings under 1 hour do not need the hose stream test. Again, that's just for walls. It does not apply to columns, beams, or floor ceiling assemblies.
Okay, got it. Let's see. Similar to question 1, when the thickness is calculated in inches, is everything rounded to 1/8 inch lower side or up to the higher side?
I'd say look at the BXUV guide. I think in most cases it's rounded up to the nearest 16th, just as to be conservative. But check the BXUV guide. There might be other situations where you don't have to. That's usually for SFRMs. That's how those are broken down into this nearest 16th of an inch.
Okay.
These are all very good questions. Yeah.
Yeah, absolutely. Absolutely. Okay. Looking at the question box, not seeing anything further. So questions going once. Rich, have you got a contact slide up there somewhere?
I do.
You can just click to.
There we go. Thank you.
Perfect. There you go. So questions going once, questions going twice. Good group of questions, quite a few of them, and all
Yes,
good as well. Questions going 3 times. Okay, looks like we're done for today's program. A big thank you to Kevin Highland, UL Solutions, and of course, Rich Walke, consultant to the NFCA, National Fireproofing Contractors Association. On behalf of both of these guys, a big thanks for attending today's webinar. I'm Bill McHugh, the Executive Director of the NFCA, and we'll look forward to seeing you at the next webinar. And then also, don't forget, we've got education program coming up November 8-9 for the people to take that exam to determine competency if they're checking to be an inspection agency inspector for fireproofing, approved by the authority having jurisdiction, or a DRI, designated responsible individual, in the NFCA contractor accreditation program. So as well as the UL qualified fireproofing contractor program. So stay tuned, stay involved. Glad to have members. Thank you for your dues. That helps pay for what we do. And if you're not a member, we expect you to join, I guess I'll say. We hope yes, but if we don't ask for it, we won't get anybody to join. So send your check in or a credit card, and we'll look forward to having you as part of the association. So thanks again, Kevin. Thanks, Rich, and we'll look forward to talking soon with you guys.
Okay, well, you're welcome. Thanks
Thank
everyone
you
for joining.
Thanks, everyone.
Thank you.